Hello. So if you recall in our last lesson, we learned about kind of what linear functions are, um, and we learned how to graph them given 2 points. So that's our background info. So today, we're going to go into looking deeper at the slope of a linear function. So we have 3 learning targets, which are all about slope. We're going to try to learn how to find the slope of a function from equations, graphs, and tables. So first of all, what is slope? So if you happen to be a skier, a snowboarder, or a skateboarder, you might be familiar with the concept of slope. You might remark that something might seem steep or gentle. So a gentle slope, it might be like this. This would be like a green square ski slope, if you're familiar with the ski analogy. Or a steep slope might look like that, which would get a black diamond at a ski area. So slope is kind of a measure of just how steep a line is. And it can be either positive, so these would all be positive slopes. So this is like if you're hiking uphill, so it would be like hiking up a steep mountain. And then we could also have negative slopes, which would be like this, and this is like skiing down something, for example. So what slope is in functionality is just how steep a line is. And as slopes get steeper, they get more positive, and as slopes get shallower, well, a horizontal line would be flat. This would have a slope of 0. And then as slopes get more negative, they get steeper in the negative direction until you have a line that's going straight down, a vertical line. So that's what slope is. Our mathematical definition of slope is that slope is the rise over the run of a function. Mathematically, I'm not sure why we do this, but we often use an m to represent slope. And our equation for rise over run would be change in y over change in x, which we could write as for any 2 points. So for the point x1, y1, and x2, y2, we could write this as y2 minus y1 divided by x2 minus x1. And this is a formula, this is probably the formula that we'll be using the most to determine slope. So first we want to look at how do we find slope of a linear function from a table of values. So I'm just going to erase this diagram real quick. And to find a slope from a table of values, so let's see, we have x, y, -2, -1, 0, 1, 2. So in a table of values, in this one we're given 5 points. A table of values has to have at least 2 points. So we can pick any 2 points and then use that equation. So if we say x, we need an x1, y1, and x2, y2, so we can pick any of these points. So let's pick -1, 9, and 2, 21. And then we could just use that formula. So y2 is going to be 21 minus y1, which is 9, divided by 2, which is x2, minus a -1. So on top we're going to get 12, and on the bottom, minus a negative is equal to a positive, so we'll get 2 plus 1, which is equal to 3, and our slope would be equal to 4. And if we look at our table, we notice each time we move right 1 unit in x, we're going up 4. For practice, we could pick another point to see if it works. What if we pick 1, 17, and 0, 13? So if we pick these 2 points, we're going to get 13 minus 17, and then 0 minus 1. It's going to be a negative 4 over negative 1. Negative divided by negative is positive, so you'll get a positive 4. And you notice that it didn't matter that the first point was further down than the second point, we still get the same answer. And here you'll notice one of the defining characteristics of a linear function is the slope is always the same. No matter what points we choose, it's always going to go up by 4 units. So later on, when we look at quadratic functions, cubic functions, exponential functions, we're going to run into cases where the slope is not always the same. But for now, for this unit, between any 2 points on a table, our slope is going to be the same. So, let's do one more quick example. What if we have -1, 0, 1, 2, 3, and let's do -4. Let's do -9/2, -5, -11 over 2. Let's do -6. So in this case, we have some fractions, but we're still going to use the same process. So we're going to have x1, y1, and x2, y2. Let's choose this point and this point. So we have 1, -5, and we have 2, -11 over 2. We'll get -11 over 2 minus -5 over 2 minus 1. So in order to subtract these fractions, we're going to need to find a common denominator. A minus, that's a positive, and 5 is equal to 10 over 2, and 2 minus 1 is just 1. So that's going to be equal to -1/2 over 1, which is just equal to -1/2. So the slope of this line is -1/2. And generally with slopes, we always want to leave them in fraction form. So we wouldn't want to convert this to a decimal. And you'll see this why in our next lesson when we're graphing functions. So in this case, we also could have looked at our change in y, and looked at, hey, each time we're going down 1/2 with each step. So that would have been another way to look at it. We could have made it easier on ourselves by using maybe these 2 points, because we could have done, then we would have had -6 minus -5 over 3 minus 1. We've got, this is a plus, so we'd get -1 over 2. We'd get the same answer. And so that is just again an illustration of how you'll always have the same slope on a linear function. So that is finding slope from tables. So now we're going to look at finding slopes from graphs. So with graphs, we're actually going to use the same formula. We're just going to look at what is the change in y over the change in x for the line. So we could just pick 2 points, any function. So let's pick this one and this one. And you notice our change in y is plus 3. It's going up 3. And our change in x is plus 1. So our slope would just be equal to 3 on this one. And once again, we can pick any two we could pick this point and this point. We could pick this point and this point. And we could look at, okay, if we want to look at these 2 points, for a rightward change of 2 units, we're going up 1, 2, 3, 4, 5, 6. You get 6 over 2, which if we simplify that, is equal to 3. So again, no matter what 2 points you pick, we're going to have the same slope. Let's look at this one. My apologies, it's not the the smoothest line. It's not supposed to be bumpy like that, but so in this one, if we look at these 2 points, so our change in y between those 2 points, we're going down 2. So if we're going down, we have to have a negative in our change in y. And we're still going right 1, so we get negative 2 over 1, which is equal to negative 2. And you'll notice if our graph is going up this way, it's going to be a positive slope. If it's going down that way, it's going to have a negative slope. And once again, if we wanted to, we could pick any 2 points. Look at the change. If we pick this point and this point, we could see that we're going down 1, 2, 3, 4, 5, 6, 7, 8. And we're going right 1, 2, 3, 4. Negative 8 over 4 is also equal to negative 2. And for this example, our last one, we have 2 functions to look at. This time, we'll notice our change in y, if we're going up 1, we're going right 1, 2, 3, 4. So those are cases where we'll have our slope be a fraction for our top one. And for our bottom one, we're going down 1 and right 2. So our slope would be negative 1/2. So that's why we want to generally put slopes in fraction form, is because it makes them easy to analyze from here and graph. So that is how you find the slope of a linear function from a graph. And now, the last one we're going to do is going to be finding slope from an equation. So this is probably the trickiest one. So the good news is if we recall from last lesson, we introduced slope-intercept form. And m is always going to be our slope. So if our function is already in this form, all we have to do is look at this number and we can say, okay, our slope is negative 3. Similarly, if we have y is equal to 1/6 x minus 80, we just look at this number, the number that x is being multiplied by, and say, okay, slope is equal to 1/6. So it gets a little bit trickier if we have, say, 3y minus 5x plus 2 is equal to 18. So if we have a linear equation that is not already in slope-intercept form, we have to put it in that form. So we could start by subtracting 2 from each side. We get 16 is equal to 3y minus 5x. Then we would add 5x to each side. We get 3y, 5x plus 16. And then we divide each side by 3. And we get y is equal to 5/3 x plus 16 over 3. now that it is in slope-intercept form, we can say, okay, our slope is equal to 5/3. So I'll just do one more example real quick. What if we have 5y, well, let's do another number, let's do 1/3 y plus 4x is equal to 2. So in this case, we start by subtracting 4x from each side. We get 1/3 y is equal to negative 4x plus 2. And then we multiply each side by 3. And we get y is equal to negative 12x plus 6. And our slope would be equal to negative 12. So that will conclude our lesson for today. And in our next lesson, since we now know a lot about the x and y intercepts and the slope, we're going to combine those and look a lot at slope-intercept form and how to graph linear equations more easily when we're just given an equation. So stay tuned for that.